Hey everybody, welcome to the virtual workshop of Elastic Scaling with Amazon DocumentDB. My name is Vin. I'm one of the senior product managers on the team. And joining with me today is Pratik. Pratik, you want to introduce yourself?
Hello everyone, my name is Pratik and I'm a senior product manager at DocumentDB with Vin.
Yeah, and we're super excited here to be here today to share with you a lot of demos, as well as just explain a lot of things around Elastic clusters to help you get started with the feature. Okay, so for the workshop agenda today, we have this roughly split up into 4 parts. So in the first part, we're going to be covering an overview of Elastic clusters. So in this section, I'll be covering core concepts and architecture, which will be referenced throughout the workshop. So stay tuned for that. In the remaining second, third, and fourth parts, we're going to be covering a lot of demos. In the second, we're going to be discussing and planning your first Elastic cluster planning, and then we're going to be showing you a demo how to get started and creating a Elastic cluster. In the third, we're going to be creating a dashboard and using CloudWatch to monitor that newly created Elastic cluster, which you did in part 2. And in part 4, in the last part, we're going to be talking about scaling your Elastic cluster, as well as some of the scaling strategies. All right, so with that, let's get right into it. So in the first section, we're going to be covering what Amazon DocumentDB is, the overarching theme. We're going to be covering why we built Elastic clusters. We're going to be covering what Elastic clusters is, as well as some of its capabilities. Then we're going to go into some architecture and cover how it works. And then finally, we're going to close this out with pricing before we get into part 2. All right, so what is Amazon DocumentDB? So for those who are not using DocumentDB yet, or you're considering it, DocumentDB is a scalable, highly durable, and fully managed database service for operating MongoDB workloads. So if you have a NoSQL JSON workload, document JSON workload, DocumentDB could be a great fit. But let's dive into some of the key characteristics of this feature so that you can learn a little bit more. So the first characteristic I want to cover is that it is fast and scalable. With instance-based clusters, the key callouts here is the ability to scale up to 64 TB of data and support up to millions of reads per second. And we'll see how Elastic clusters exceed some of these limits. Next is the ability to handle administrative tasks. So DocumentDB, the key idea here is that we handle those administrative tasks so that you can focus on your applications. So things like high availability, durability, and automated patching are in place so that you can focus on building your app. And the last but not least is MongoDB API compatibility. Now, with DocumentDB, you could use your existing MongoDB drivers and tools with DocumentDB with little or no change. And we support hundreds of APIs for operational and analytical workloads. But I think that the most important thing here is that we're constantly listening to you and constantly working backwards from your needs so that we can build the right features for you. Now, over time, some of our customers have been growing with the service and have asked for more storage and more compute for their workloads. So they shared this requirement with us. So we asked ourselves, how can we scale more? How do we offer more storage and more reads than what's available in our product today, especially with instance-based clusters that's highlighted in orange? So we took that requirement and we feeds into the motivation behind Elastic clusters. So let's walk through an example to show you how we actually approach this problem to enable more scale. So let's imagine for a moment that your digital documents were physical ones. So here you have a physical document, and you would store these physical documents in filing cabinets. So you imagine you would go to Staples or Office Max or your favorite stationery store. You get a filing cabinet to work with your physical documents. Now, over time, as your business grows, you're doing amazing, fantastic. You go back to Staples and you ask for a larger filing cabinet and a bigger filing cabinet. Now, at some point, your favorite stationery store may not have a tall enough or big enough filing cabinet to work with all your documents. And even if they did, and even if you could get something customized, it may not be that practical. So realistically, what you're more likely to do is to go back to your stationery store and get multiple filing cabinets. And from there, you actually partition out your documents across the filing cabinets. And this is very analogous to databases, where the concept also applies to very large database systems. So if you're working with a lot of data, you might consider partitioning out your data as well. And you might have heard of this concept through other terms such as horizontal scaling or sharding, which also describes partitioning your data out in your database. And that's the approach we took with elastic clusters. With the elastic clusters, this is a new type of cluster for DocumentDB, and we can support up to millions of reads and millions of writes per second with petabytes of storage capacity. So here's a screenshot of that in action. What I'm pointing to in the screen is the number of documents being inserted into my database, which is 73 million documents per minute. And if you divide that by 60, you'll get that over 1 million documents being inserted per second. And each one of these rows beneath it is actually the number of documents being inserted per shard. And I'll get into what a shard is in a bit. But effectively, these shards work together. And in sum, that's how we get that 73 million number that you see in the very top on the cluster level. Now let's take a look at some of the characteristics of this type of cluster of Amazon DocumentDB Elastic clusters. Very similar slide to what I showed you earlier. Under fast and scalable, the key call out here is that it can handle millions of reads and millions of writes, as I mentioned earlier, with petabytes of storage capacity. And under fully managed, the key idea here is that we continue to be fully managed so that we help you focus on your applications. So things like high availability, durability, and security is enabled by default. And we also offer automated patching and monitoring and alerting built into the product as well. And of course, MongoDB API compatible. So we're going to remain being MongoDB API compatible. You can use your existing Mongo drivers tools with Elastic clusters with little or no change. We continue to support hundreds of APIs, operators, and stages for analytical and operational workloads. And we continue to work backwards from your needs as well. Okay, so I already hinted at how this works with the approach earlier, but let's dive a little deeper and take a look at the architecture diagram to show you how this works with some additional details. Now, before I show you an architecture of elastic clusters, it's useful to understand the architecture of an instance-based cluster. In short, we have the separation of compute and storage of instance-based clusters, and this enables us to scale the storage and compute independently. For example, here, I could add or remove additional instances, or what I can do is scale up all these instances to a larger instance type for more compute. And we can all do this in near constant time because there is no data movement between the instances as I'm doing the scaling action. And the storage also scales independently of the compute by adding more partitions of data, which we handle under the cover. Now, DocumentDB instance-based clusters are already plenty scalable. Our compute tier can handle tens of thousands of writes and millions of reads per second by adding additional instances. And our storage layer is also very, very scalable, where we handle terabytes of storage capacity without the need for horizontal scaling. Now, for elastic clusters, what we've done is we've taken this instance-based cluster architecture and we've used it as a fundamental building block for elastic clusters. So let's just watch this animation in a bit, where effectively what we're doing is using each one of these clusters in our elastic cluster as a component. So with elastic clusters, each one of those instance-based clusters effectively becomes a shard. And each one of these shards has its own writer as well. So together, that's how we're able to achieve that millions of writes per second and petabytes of storage capacity, because each one of these shards work together to help us achieve those higher scaling limits. Now let's see how that data is actually partitioned in our Elastic cluster. So here we have an example data set of documents that contains our name, our last name, a role. We also have a shard key, which we'll go into in a little bit more in a bit, as well as a phone number. So to take full advantage of Elastic clusters, you'll need to create a sharded collection instead of a regular collection, which tells the system that you want your data to be sharded. And one of those things that you'll need to specify for a sharded collection is a shard key, which tells the Elastic cluster how you want to partition out your data. So let's see that in action. What we do with the shard key is we run it through a hash function, and in return gives us a hashed value. So think of it as a randomizer. And this helps us more evenly distribute the data across the shards. So you can see here that our documents are evenly distributed across the shards, and we achieve that using hash sharding. And when you add or remove shards, that data is automatically repartitioned so that you don't have to go through manual movement of these chunks of data between the shards. So if you add shards, we automatically move some of the data to the new shard. If you remove shards, we automatically move it back. And in the next section, we're going to talk a little bit more about selecting a shard key and how that helps you as part of the planning process. Now, before we go into planning and creating, one question that I always get is, how is this priced? So let's go with that first. With Elastic clusters, there are 3 pricing dimensions. There's compute, storage, and backups. With compute, you count the total number of vCPUs in your cluster, and you multiply that by the per vCPU rate, and that becomes how much you pay per hour. With storage, you get billed by the gigabytes per month, and this is the same as many of the other database services in AWS. So very similar from that regard. And the last is backups, which is also billed at per gigabyte per month. Also very similar to the other database services in AWS as well. Okay, now that I've provided an overview and we've covered some of the core concepts and the architecture, I'm going to pass it over to Pratik, who's going to explain how to plan and create your first Elastic cluster.
Well, thank you, Win. In this section, we look at planning process prior to creating an Elastic cluster, create a DocumentDB Elastic cluster using AWS console, and finally run CRUD operations in the newly created cluster. So, did Vin mention that you need a shard key to distribute the data? To leverage Elastic cluster the best way, you need to create a sharded collection where data is distributed across different physical shards to improve query and load distribution across the Elastic cluster. And it all starts with selecting a shard key. But what makes a good shard key? Let's look at how to select a good shard key through commonly occurring challenges in database. Let's assume that you are using Amazon DocumentDB Elastic cluster as an operational database for your retail business and capture order details in a collection. You start by choosing the store location as the shard key. With time, as your business in California grows, like every good business should, your order volumes in California also increase disproportionately, as provided by the orange JSON files here. This is a good problem to have, but the choice of shard key creates an uneven data distribution. Your storage resource is overutilized in one shard and underutilized in the other. Let's look at another challenge. Large data volume on a shard also affects the read and write traffic to the shard. With a growing business in California, the shard with key value as CA would incur more reads, inserts, and updates, generating more traffic to one particular shard. Uneven load distribution would also occur when an even data distribution is present in your Elastic cluster. Now let's look at the final challenge. Let's assume your queries do not contain the shard key. Therefore, they don't get routed to one particular shard, but to all shards present in your Elastic cluster. This is what's called a scatter and gather scenario. All your shards are overutilizing cluster resources to return query result. Even if you assume even distribution, this challenge still persists. To summarize, you need to plan around three challenges: an uneven data distribution, an uneven load distribution, and scenarios that lead to scatter and gather conditions. So, going back to a question, what makes a good shard key? A good shard key should have high cardinality for a field with large number of unique values. Secondly, a good shard key should evenly distribute your data and load across your shards. And that is determined by your workload patterns and application requirements. Thirdly, it should be present in most operations. Insert and update queries should definitely contain the shard value, but read queries should also rely on the shard key to avoid scatter and gather conditions. You also improve cluster scalability requirements when incoming queries are routed to only one of many shards in your Elastic cluster. Let's look at an example of an orders collection with fields order ID, purchase date, customer ID, product ID, store ID, and state, and apply the recently learned good sharding principles we just looked at. We observed that state could be a bad candidate for shard key. To improve cardinality, we could select product ID or customer ID, which provide a high cardinality. Secondly, product ID and customer ID also distribute load across shards more evenly than state field could. Finally, a good shard key should be present in most queries that you run. Like in this example, find query, if your application queries often rely on retrieving and updating customer or product information, a customer ID or product ID would be a better shard key. Now let's switch to AWS console to create an Elastic cluster and a sharded collection. To create your first Elastic cluster, head over to Amazon DocumentDB page in AWS Management Console. Go to Clusters and click Create. With Amazon DocumentDB, you can create instance-based and Elastic clusters. For today's demo, we're going to create an Elastic cluster. First, specify the cluster name. I'm going to go with Elastic Cluster. Next, you get to specify the shard count and the shard capacity. Shard count is the number of shards in your Elastic cluster. This can range from up to 64. For the demo, I'm going to choose 2. Shard capacity is the number of virtual CPU in each shard. For the demo, I'm going to select 2. Further, you get to also specify networking details for Elastic cluster. The creation flow provides you default options for VPC subnets and security groups. Further down, under authentication, you get to specify the username and password. Further ahead, under encryption, you get to specify the KMS key that is used to encrypt data at rest. By default, data at rest stays encrypted in your storage volume. And here you get to specify the KMS key that is used to encrypt and decrypt the data. You can either choose a default key that's owned by AWS or specify a custom key that you created. I'll go ahead with the default key. Further, you can also specify the maintenance window during which your cluster goes through maintenance. For the demo, I'm going to select no preference. And finally, you get to provide tags to the Elastic cluster. This is a great way to track expenses across different resources in AWS. And that's it. Let's create our first Elastic cluster. This might take some time. So for the rest of the demo, I'm going to use an existing cluster to walk you through simple CRUD operations. I'll be using Super Elastic Cluster. When you click the cluster, you get to go over the configurations, monitoring, and connectivity details of the cluster. Let's copy the connection string. I'll be using an AWS Cloud9 environment to access my Elastic cluster. This is a virtual ID that runs in an EC2 instance connected to your Elastic cluster. Both the EC2 instance and the Elastic cluster need to be in the same security group. Let's use the connection string that we copied earlier. There we go. We are now inside the Elastic cluster. Let's start by creating a sharded collection. Here, I'm creating a sharded collection orders inside database DB and providing product ID as the hashed shard key. Next, I'll insert a single document in this collection. If you look closely, this is similar to the example that we were looking at. You get to also find and query documents that have been written to your Elastic Cluster collection. Similarly, you get to also insert many documents and find them many at a time. There you go. You have your first Elastic Cluster running. Let's switch gears now to understand how we can start monitoring this newly created Elastic cluster by setting up a dashboard and alarms to get notified of key cluster events. Amazon DocumentDB integrates with CloudWatch so that you can gather and analyze operational metrics for your clusters. You can monitor these metrics using CloudWatch console, the Amazon DocumentDB console, AWS command line, or the CloudWatch API. CloudWatch also lets you set alarms so that you can be notified if a metric value breaches a threshold. You can even set up Amazon CloudWatch events to take corrective actions if a breach occurs. With CloudWatch integration, you can measure the health and performance of your Amazon DocumentDB cluster and instances. And these are some of the metrics that you can start tracking today. Like in an instance-based cluster, you can track Elastic Cluster's performance at a cluster level for overall health using Amazon CloudWatch. Additionally, Elastic Cluster provides insights into shard-level metrics, which can be very useful to identify bottlenecks and skewness in your data and workload patterns. The peak-to-average ratio of your per-shard metric is particularly interesting and helps you determine whether you are driving uneven traffic, commonly called hotkey hotspot, to a specific shard. Finally, CloudWatch alarms can be used as an early warning system to determine whether to update cluster resources accordingly. You can create a CloudWatch alarm that sends Amazon SNS message when the alarm changes state. The alarm can also be configured on one or more actions based on the value of the metric relative to the given threshold. Let's switch over to AWS console now, where we create a CloudWatch dashboard to monitor a DocumentDB Elastic cluster and create an alarm to improve its observability. To start monitoring your Elastic cluster, head over to CloudWatch in AWS Management Console. Make sure that you're in the same region where your Elastic cluster has been created. Go to Dashboards and create a dashboard. Let's call it Demo Dashboard for today's demo. We want to get notified and alerted on CPU and memory resources. So a line graph could be a good choice. Once you select line graph, you get to see different metrics that are presently available. Here, head over to DocumentDB Elastic. You can see that for DocumentDB Elastic, you can start monitoring metrics at a shard level and at a cluster level. Let's head over to shard. I've been using Super Elastic Cluster, so I'm going to filter for metrics pertaining to Super Elastic Cluster. I want to get notified about CPU utilization, so I'm going to filter further for CPU utilization and select the primary instance in each shard. Here you can notice the orange and the blue line denote the primary instance of each shard. Next, head back to DocumentDB Elastic Metrics and go over to Cluster Metrics. The same filters that you selected apply. This time, I'm going to again select primary instance. Because this is a cluster metric, it represents the average of both shard instances, primary instances. You can see that the green line denoted by the average cluster metric sits in the middle of the orange and blue line. I'm going to now add this widget to our dashboard. There you go. We added our first graph to our dashboard. You can add more metrics like memory and document inserted by repeating the same process, heading over to shard, selecting your cluster, the metric, and selecting the overall cluster metric. Now I have a dashboard that monitors the CPU and memory resources being consumed by the two shards and the cluster. Let's go ahead and save this dashboard. If you head back to the overall dashboards page, you can see your demo dashboard is now created and can be accessed anytime. For the next part of this demo, we're going to create an alarm. Alarms can be integrated with Amazon SNS, which can send you alerts to an email that you or your team uses. Head over to create an alarm. In this case, we're going to create an alarm for CPU utilization. The screen looks familiar again. Right? You have metrics and you have DocumentDB Elastic metrics in it. Maybe you want to get notified when the primary instance on one of your shard is consuming 70% of its available CPU. So we're going to go over the same process. Select the cluster, the metric, and the type of instance. If you look closely, alarms do not allow you to select multiple metrics. So we will go ahead with a single shard and its primary instance and select that for a metric. We're going to set a threshold. So when CPU exceeds 70%, we will be alerted. Create a new topic for this alarm. Call it CloudWatch alarm. Provide the username and create the topic. Make sure that you head over to SNS console and go over the final integration steps to ensure that the alarm notification is sent to the email listed here. Finally, provide it a name. So I'm going to call it demo alarm. I'm going to skip this part, but make sure that you add a description here too. There we go. This is our first alarm that we have created. Here you can see that the alarm that you created is now present in the alarm console. Select the alarm, and now you can add it to the dashboard that we had created before. Under demo dashboard, now you get to see the two graphs and the alarm that you created. Well, this is extremely useful when you want to know when your CPUs for both your shards, for the instance of the primary instances of both your shards, are operating at peak capacity. You may want to consider scaling up or out your instances. I'm going to hand it back to Win, who's going to walk you through how do you scale instances the right way. Back to you, Win.
All right, thanks, Pratik. That was a great overview of monitoring as well as planning and creating your Elastic cluster. So let's assume that you've created your cluster, you've been monitoring it for a while, and now you have the need to scale it up. How do we go about that? So in this section, I'm going to be talking about scaling your Elastic cluster. We're going to be talking about scaling up. We're going to talk about scaling out, which is the two different ways you can scale up your Elastic cluster. And then we're also going to talk about when you should scale out versus scale up. We're going to cover through a few scenarios, through some examples. And then last but not least, we're going to cover a demo on how you could achieve this. Okay, let's first talk about scaling up. So with Elastic clusters, you can scale up the shard capacity of all the shards in your Elastic cluster. So in this diagram, I have three icons: shard 0, shard 1, and shard 2. And if you are to scale up, effectively what you're doing is you're increasing the shard capacity of the existing shards. So you can see here denoted by a larger icon, what we're doing is we are replacing the existing shards with a larger shard capacity. And each one of these shards can scale up to 64 vCPUs, and it could be scaled down as low as 2 vCPUs. Now, in terms of scaling out, what we're doing is we are adding additional shards to our cluster. So this is the other type of scaling. So here it could be denoted by adding two additional icons here of the database. You can imagine with shard 3 and shard 4 being added as well. And with Elastic clusters, you can start with as small as 1 shard, and you can scale up to 32 shards. And each one of these shards, in conjunction with scaling up with 64 vCPUs and 32 shards, the maximum cluster size is 2,048 vCPUs. So that's a very, very large cluster compared to the largest cluster size today of instance-based clusters, which is just 64 vCPUs on a Graviton instance. Now, so the question that we have here is, when should you scale up and when should you scale out? Now, if you are anticipating spikes in the short term, such as an increase in traffic, like a e-commerce website that has an event that happens for a week. So let's say you're running e-commerce, you have a sale coming up, and you know that you're going to be running a lot hotter for your workload for that week, then scaling up makes a lot more sense. Scaling up and down is also faster compared to scaling out because there is no data movement between the shards, and we'll cover that in a bit. If you are anticipating growth in the long term, and you know that you're going to continue to grow, increasing the number of shards is likely a better way to go long term. So, for example, if you are seeing steady growth with your business, such as you are seeing steady user growth or more documents over time, then scaling out may make more sense. You should also consider scaling out if you need more storage, as each shard adds additional data. Now, one thing, whether you are scaling up or out, it is a best practice to scale during non-peak hours. With scaling operations, there are small windows during that time when we do a cutover, and there could be some intermittent errors. So it is best to scale during non-peak hours. So let's look at some of these scaling examples through through our architecture diagram. So here's another visualization in a little bit more detail. So let's say we're scaling out from 3 shards to 4 shards. Here's what it would look like. We would first provision that additional shard. And under the cover, what we would do is perform some of that data movement and data rebalancing between the first 3 shards to that 4th shard. So this is handled under the cover by our service. You do not have to do any of this data movement yourself. We handle that for you. Now let's take a look at scaling up. Now, if you are scaling up through this architecture diagram, here's what it would look like. It's very similar to increasing the instance sizes within instance-based clusters, but instead we're doing it on a shard level, and each one of these has its own writer. So one thing to note here when you're scaling up or down is that there is no data movement in this scenario. So notice that I am just really increasing the compute capacity of the existing shards. And very similar to scaling out, scaling for storage, if you are looking to increase the scale, if you're looking to scale to increase storage capacity by adding a new shard, you can achieve that. So each shard, by adding a new shard, you also get its own set of distributed storage volumes. And by doing so, you're removing some of the data from shards 1, 2, and 3 to shard 4. And if you're shrinking the number of shards, some of that data from shard 4 will move back into shards 1, 2, and 3. A second call out here is that when you scale up by adding additional shard, you're also reducing the volume being used in shards 1, 2, and 3. That frees it up for future usage as well. So let's take a look at a scenario where you have two different clusters. Let's assume you've tested your workload on both these types of configurations on both these systems. So let's say that one system has 2 shards with 32 vCPUs each, and the other has 4 shards with 16 vCPUs each. Let's assume, again, that the workload that you've tested works the same or very equivalent on both these systems. And the question arises, which one of these systems is better to handle short-term compute spikes? Which one is actually better to for that type of scenario? As mentioned earlier, if you have a short-term compute spike that's required and you need more compute capacity, scaling up the shards is better because it is faster compared to adding more shards to your cluster. So in the top configuration, you can scale up both of these shards up to 64 vCPUs, but then that's the max. From that point on, you would actually need to add more shards so that you can actually continue to scale up and handle more capacity. And adding more shards, as we know, and as I mentioned, does involve some data movement to that new shard. So it will take a little longer to complete. Now, in the bottom scenario, in the bottom configuration, you could scale up to 32 vCPUs. So that's doubling, and then up to 64 vCPUs, which is 4 times the amount of vCPU capacity until you need to add more shards. So in this example, the bottom configuration is actually better to handle short-term spikes. Also to point out that you also want to leave some headroom so that you can handle these spikes. If you were in the top configuration was 64 vCPUs instead of 32, then you won't have any capabilities to actually scale up any further. So what we would recommend in this scenario is actually try to convert your top configuration into the bottom configuration if you can. Beyond that, the cost for both of these scenarios is actually the same. So you would actually increase the number of shards from 2 to 4, and then you could reduce the compute capacity from 32 to 16 so that you can actually have more headroom to handle those compute spikes. Okay, so we're going to swap over to our demo environment where I can show you how you can scale. We are now in our demo environment, and so we have our stretch 9 elastic cluster where it has 4 shards and 4 vCPUs. So if I want to change the configuration of our cluster, such as scaling up or down or in and out, I would just click on this modify button. And the first thing on this page that you'll see is the shard count and shard capacity. And as I mentioned earlier, the shard count can be changed to as little as 1 and could be as many as 32. So I could change this to 1 or I could change it to 32, but I'm going to leave this as 4 for now. And under shard capacity, what you could do is change the amount of vCPU capacity per shard. So again, this can go as little as 2 vCPUs per shard and up to 64. So in our demo today, I'm just going to change it to 8. And on this page, we are not going to change anything else. For example, the maintenance window, the authentication or network settings that Pratik mentioned earlier. We're just going to keep these settings as is. And when we're done, we just click on modify. So you can see here that your Stretch 9 cluster is being modified. So let's take a look at that. So you can see here now that's currently in its updating state. Effectively, we are updating all the shards in our cluster. And that's how easy it was to actually change the configuration of our shards, such in this case, scaling up. So this is going to take a little bit to finish, but that's just how easy it is to scale up and down just by changing a few numbers in our cluster. So we're going to switch back to our slides. Okay, and that brings us to the end of that section. But one thing, just one more slide before we go to our Q&A. If you are not using DocumentDB yet and you wanted to give it a try, I'd like to call out that there is a free trial. So you could scan this QR code and we'll provide you a free trial. There's up to 750 hours of compute that you can use for an instance type. We also include IOs and storage and backup as well. And if you're already using DocumentDB and you want to give Elastic clusters a try, you could follow the steps that we shared with you today, and you can go into the console and just follow the steps that we showed with you earlier today to create your first Elastic cluster. And with that, we're going to go to our Q&A. Pratik and I are going to stick around to answer any questions that you might have. So please feel free to put it in. Please feel free to ask those questions, and we'll get to them as soon as we can. And with that, thank you.